Welcome to this second lecture on digital computer electronics. We are discussing about number systems and their interconversions in the previous lecture. Now we are going to discuss about the addition, subtraction, multiplication, division of various number systems, and we'll also have the subtraction through 2's complement method, and we'll also try to see the representation first. Last time I have shown you that how the numbers can be represented only in binary. Then if the binary digits are separated or made in groups of 3, separated in groups of 3, they make the octal system, and if they are separated with four digits, 4 binary digits, then it makes an hexadecimal system. Now we'll try to see how the information on lines can be represented in octal, binary, and hexadecimal system. If we have 12 lines starting from LSB to MSB, this 12 line bus is having 12 bits of information. It's having 12 bits of information. The red one is indicating that the information is 1, and the green one is indicating that the information is 0. If we represent it as a binary information, we have to take every single line and represent it separately as indicated on the top, that the red line will be representing 1 and the green lines as 0. But in the second bottom right, if we take the groups of 3, starting from the LSB, we take the groups of 3 lines together and then represent the group together, it will make an octal system. And instead, in the bottom left, if we take 4 lines together, it makes an hexadecimal system. So let's continue now with the computation of various number systems. We're starting with the addition of binary numbers. A binary number is here, it is to be added to another binary number. So we start from the right in the same way as we are doing the addition of decimal numbers. We'll try to do the addition of binary numbers, as that 1 plus 1 is 1 0. So a 0 will be there and 1 will be carry. In the same way, because it's only having the 2 digits, so the third digit is not 2 is not there. So let's start this addition. If we start from the rightmost, 1 1 is 0, 1 is carry. That 1 along with this 1 and 0 is again 0, 1 is carry. Then 1 along with this 1 and 0 is again 0 and 1 is carry. Then 0 plus 0 is 0, but the carry 1 will get added here and 1 will be here. So 1 1 is again 0, 1 is carry. That 0 plus 0 is 0, but the 1 carry will sit here. So then again 1 plus 1 is 0, 1 is carry. That 1 along with this 1 is 0, that 1 is carry. Then 1 plus 1 is actually 1 0, but the carry will make it 1 1. So this is the addition. So this is the binary addition, and you can just repeat this and understand again that how the binary addition is carried out bit by bit. Then have some exercises on this, and with the practice it will be easier. So now let's take the binary subtraction. In the binary subtraction, if I have the same numbers, say that were in the previous example, but would do the subtraction instead. So what's there? That we'll start from the right most with 1 minus 1 is 0. Then 1 cannot be subtracted from 0. Then 1 borrow will be taken from here. The same way it will be, then 1 0 minus 1, that is 1 will be the result, and here it will be 0 again 0, and 1 minus 1 is 0, again 0, again 0, again 0, again 0. So this is the result. Take the extra examples to understand the system. Now let's take the addition of octal numbers. In the addition of the octal numbers, we have let us see that this is system of 8 digits from 0 to 7. So whenever we are making the additions, we have to consider that we have only available 8 digits from 0 to 7. Let's take an example. This 5 is to be added to 3. We'll start this addition. 5, 6, 7 and 1 0, because 8 is not there, so it will be 1 0. 0 will sit here and 1 will be carried. That 1 along with 2 and this 2 make 5. And then we have this 7 to be added to 5. 7, then 1 0, 1 1, 1 2, 1 3, 1 4. So the result will be 1 4. So take simple examples again. Try to have as many examples as you can solve at your home. So this is the octal addition. If we take the octal subtraction, in the octal subtraction, with the same example, 5 minus 3 is 2. Then 6 cannot be subtracted from 12. Then we can take 1 from here, but that 1 is actually 8. This 8 plus this 2 will make it 10. Then 6 are to be subtracted from this, that the result will be 4. Understand me, that when I am taking 1 from here, it will be 8s. It will not be 10s, it will be 8s. 8 is taken from here. So when I take 1 from here, I am taking 8 from here. It is the base of 8. So this 8 plus this 2 will make it 10. 10 minus 6 is 4. So in the same way, now I have 4 and 4. That will be 0. So in the same way, take as many examples as you can to have a good practice for this octal subtraction. Now let us move to the hexadecimal. Now we are not having only 10 digits, we have more digits, 16 digits from 0 to F. 0 actually is representing 0 to 15. So if I add, C is the number, C is actually, after C I have to add it 5. C, D, E, F. 1 0, 1 1. So 1 will sit here and 1 will be carried. That 1 along with this F is 1 0, 1 1, 1 2. So 2 will remain here, 1 is again carried. That 1 along with this is 1 0. That 1 0 and A will make it 1A. Then A will sit here and 1 will be carried. That 1 along with this 5 is 6, 7, 8 and 9. So this is the hexadecimal addition. Take as many examples as you can at your own. Now the subtraction problem. Again, see that C cannot be subtracted from 5. C is actually 12, and out of if I have to subtract it from 5, I have to take 1 borrow from here. I'll take 1 borrow from here. That 1 will be equal to 16. 16 plus this 5 will make it 21. 21 minus 12 is equal to 9. So 9 will be the result. Now here I have 1 and f cannot be subtracted from this. So I'll take 1 from here. So it will become 16 plus 1. So it will become 17. So 17 minus 15 is 2. So now I have here 9. 9, f cannot be subtracted from 9. So I'll take 1, borrow from here. That 1 will, along with this 9, that 1 16 plus this 9 will make it 25. 25 minus 15 is 10. Not 10 but A. We'll write A. And then we have the 4. 4 minus 3 is 1. So this is the subtraction. Again, take some examples to increase the perfection. Now let's move and watch this. These were the examples we are doing. This is an addition problem. Again, this is the octal addition. These examples we have, but see that if I take these numbers in binary, and you'll see that octals will be represented as in 3 binary groups. So take them, make them like this, then add them. So it will become the same thing. So we are making octal additions. Instead, if I have made binary addition, there is no problem. We have to put only commas and separate the things. So it will be equivalent. So in the same way, if we have the hexadecimal, we'll put it in the binary representation, then separate by the commas and represent after addition in the same way. So the octal or binary or hexadecimal is the same system. It's only that it's the grouping. If I take the groups of 3 binary digits, separate them and represent them as numbers, then it becomes the octal system. And if I take the 4 at a time, then it becomes the hexadecimal system. You can watch again for the subtraction as well. The same thing, same examples which I have done earlier. Same examples can be taken by doing it only in the binary form. Now the subtraction using 2's complement. So first we have to understand what actually is the 2's complement. If we have the 2 numbers and we have to subtract them, we use the method earlier. This is the simple subtraction. But there is another way in which we actually carry the subtraction in the arithmetic logic units, is using the addition. By using the addition method, but taking the number which is to be subtracted as negative. So in the representation of the numbers inside the machine, it is that the numbers are represented as positive or negative numbers based on the most significant bit. If that bit is 1, it's negative number, and if that bit is 0, that is a positive number. So, but how this addition can take place to produce the result of the subtraction? You see that we have a particular number. The second is to be subtracted. So what I have done to the second is I have taken it is 1's complement. 1's complement means that wherever there was 1, it is to be replaced by 0, and wherever there was 0, it is to be replaced by 1. So this is called 1's complement. So if this 1's complement is now added to the number, the result will get generated as this. The number is this 341 in decimal, and 307 is subtracted from this, then the number subtraction result must be 34 in decimal. So if I see this number, this is not 34. So this 1's complement has produced a result, it is only 33. What is done actually is that this number which is generated as carry is not actually to be taken. It is actually the subtraction result. That what we have to do, that we have to change this number to 2's complement. What 2's complement is adding 1 to the 1's complement. So how we do it? Take the addition, then add 1, and it will get the required result. So you have added 1 to the 1's complement, or added 1 to this result which was generated through the 1's complement, added 1 to this, so we got the result of subtraction. This is now 34. So again we'll see that what are signed representation of numbers. Suppose I was having number 7, so it will be represented as a number 0000 in the hexadecimal, and the binary separated as hexadecimal. Then the hex code will be 007. So this represents actually, because of this last bit being 0, it represents plus 7. So if I take it is 1's complement, these zeros will change into 1's and 1's will change to zeros, the number becomes FF8. But if I add 1 to this FF8, it will become FF9. So this will be minus 7. And this minus 7, if we have to represent, is nothing but the 1's complement plus 1, making it 2's complement. So 1's complement, add 1, makes it 2's complement, but that represents actually the negative of the same number. So in the same way, if 8 was a decimal number, and in the binary it will be represented as number 00000001001110. So if I represent it in the hex codes, it will be 004E. So this number 78 is actually 4E, and because of last bit being 0, it will be taken as plus 4E. And if I take it is 1's complement, it will be all these bits, 0 bits will be 1, and all 0 bits will be 1, and all 1 bits will be 0. So the number generated is actually FFB1. And if this is 1's complement, if I add 1 to this, it will become FFB2. This is 2's complement, and the 2's complement is actually the negative of this number. So this was representing as 4E. Now this will represent as minus 4a. This is how signed and unsigned numbers, if we have not, we do not take the bit, the most significant bit as uh, the signed bit, then the numbers are unsigned numbers. But if this bit is taken, then uh, we call them these as signed numbers. And in the ALUs, actually in the modern worlds, all systems, all computer systems, they handle the signed number systems. Multiplication of binary numbers. The binary numbers can be multiplied in the traditional way of multiplication of the decimal numbers. The method is same, and the process is like this, that if we have two numbers 1011 and 1001, they'll be multiplied like this and then added in the classical way of the multiplication. The one number is binary 1011 equivalent to decimal 10. The other number is binary 1001 equivalent to decimal 9. And the result here 11000011 is the number equivalent to decimal 99. Now let us take the division. Division in the same way, the classical method. We have number 1101010 and we have to divide it by 1100. So if we try to divide in the same way, that ones are the same number, then subtract 1 will be here, take this 1 from here, again no division is possible. So zeros are again 0 0, this one will again come in the bottom. Now 0 will come from here, again there is no division possible, that again zeros are the 0, then again one will have the remainder as 110, then only this 1 will come, then it will make it again 1101, then ones are 1100, then again we have the 0 in the remainder, so this 0 will come, the division is not possible, this 10 will be as remainder, the 100 will be the coefficient. So this is the simple classical method of multiplication and division. You can take examples of multiplication and division at your home, at your own places, and try to have as many examples as possible. So this is all about the computation of different number systems. Particularly you have taken the binary, we have not taken the other numbers. So with this we'll end today's lecture. Thank you very much.